Just to give you an example of another topic where I used this, we can take a look at an experiment about electricity generation. So in this case, I actually set up a really specific way that I had students make predictions. I gave them instructions about their experiment, and then I gave them little sheets that looked like this. I asked them, what are the 3 ingredients we need to generate electricity? And I told them 2 of them, and then I told them I needed them to experiment to see if they could figure out what the 3rd one was. But before I had them do that experiment, I had them take a guess. And I told them they could write anything they wanted in the box. If they had a guess, they could write it. They could write question marks if they wanted to. They could write, I don't know. I just wanted them to write something in the box. And then I had them take some time to do some exploring. And we're going to take a moment to take a look at an example of some people exploring with this particular experiment now. All right, so what we are going to do in our next experiment is see if we can discover what the recipe for generating electricity is. Now, we already talked about how we need a force. We need an object to give us a force. So who can tell me what is an object that gives us a force? An object that can push things or pull things. Yeah.
A magnet.
A magnet, exactly. So our first ingredient is going to be a magnet. And I'm going to give you 3 different magnets you can experiment with. But that is ingredient number 1. Number 2, we're trying to get electricity, so we're going to need some kind of a circuit. Who can tell me what is a really good material to build a circuit out of? Yeah.
A wire.
Wire. Now I'm going to give you 2 different kinds of wire. You're going to have some wire that's been wound around in a circle or a coil like this. And then we attached it to this board so it would stay in one spot and attached the ends to these little pegs here so you don't have to go hunting for the ends of the wire. I'm also going to give you some wires that have little clips on the end of them. These are called alligator clips, and you can use them to clip on to your coil of wire. The other ends of your wires are going to clip into the 3rd thing I'm giving you, which is this thing right here. Now, this is not an ingredient in our electricity recipe. This is a tool we're going to use to figure out if we have electricity. But this is an electricity meter. So if you have electricity, your meter wire will start to move a little bit. And that's how you know you've got what you're looking for. Now, the key element to this is to make sure you leave your meter sitting down on the table. If you pick up your meter and start shaking it, that's not electricity. That's you shaking your meter. So you want to make sure the meter is sitting nice and flat on the table. You have your complete circuit hooked up, and then you're going to have to somehow add your magnets in and figure out what our 3rd ingredient is. Now, before I actually give you your materials, I want you to turn your brains on for a moment and see if you have a guess or a prediction of what you think our 3rd mystery ingredient in our electricity recipe is. And I'd like you to just write what you think that thing is in this box right here. Now, if you don't know, if you have no idea, that's totally okay. You're welcome to write, I don't know. You can write a question mark. You can just put something in there to let me know that what you're saying is that you don't know what the answer is. Or if you do have a guess, please feel free to put that in the box right there. Once you're done, I'm going to have you tear off your white piece of paper and hold it up in the air. Somebody will come grab it from you, and then take your blue piece of paper and just set it face down next to you. So, ladies and gentlemen, we'll pass all of these out. I'll have each of you fill in your prediction, give me your white sheet, and once that's done for your whole group, I'll bring you your materials and you can get started experimenting. All right, let's get going. All right, fantastic. Thank you. You can just turn that upside down. And here are your materials. Go ahead and get started.
Let's use this one. It's bigger.
Yeah.
Oh, wait, there are 2 in here. Oh, we can each do one. Cool. Okay.
So you clip it here,
Yeah, I think so.
and then to here.
I think that this one goes to here.
Oh, okay.
So that it's like and then this one end goes here and one end goes here. So then it's like a circle. Yeah, I think so. Oh, does this have to be this way? I guess this has
Oh,
to go
I can-
that way.
Oh yeah, there you go.
All right, great. So it looks like you've got your circuits all hooked up.
Yeah.
So then your next challenge is to figure out what are you going to do with your magnets.
Okay.
How are you going to get that needle moving with your magnets?
Try this one.
All right, we've got one idea we're trying out over
Well, it's
here.
a magnet. And it's a wire. I'm just looking at the
yeah,
wire.
so wires.
Okay.
So it's like,
Interesting. So far we've tried putting our magnets on our meter. Okay. We tried putting our magnets on these wires.
Mm-hmm.
Let's think about what else we could do with our magnet. What else might be useful?
Maybe here. What if
Maybe-
I put it?
what if you do-
What if I do this?
like that.
Oh yeah.
Like that.
I don't think it's moving. Yeah, try tapping it. Awesome. Oh, mine came undone.
I did it like I put it inside there.
Oh, that's probably a good
easier.
idea. What if you put the magnet
Put it.
next to it?
Yeah.
Is it-
Oh wait. Like I just do that.
Ooh, what just happened?
Oh.
Oh, it moved a little bit. When it
What'd
was
you
on it. When it was on top of it.
Oh,
it
when it was
moved.
sitting on it.
Yeah.
Oh, but is it moving now?
No.
So what's different about what just happened and what's happening right now?
Well, it fell off.
Oh,
Oh, when I
What just
took it
happened?
off. When I took it off, it
Oh,
moved.
try
What happens
taking
if-
it off? Oh.
Oh, when I put it on, it moves. Wait, does that happen with yours? Try
Let me
it.
try it. Can you see?
It does wiggle a tiny bit. Mm-hmm. It's wiggling a tiny bit.
so what could you do to keep it going? Ooh.
Oh, if I keep going up and down.
Oh, that's a good idea.
Yours is doing just a
Oh
tiny
yeah,
bit.
it's just a little.
Here, try with this one.
Oh yeah, good idea.
Oh.
Oh, there we go.
Oh, this one works better on mine for some reason.
So if it goes up and down.
What is it?
Does it have to go up and down?
Would it go like in a... Oh, it works in a
Oh,
circle
that works
too.
too.
Wait, what about...
Circle?
Does this go through?
So once I had people done with their exploring, I didn't debrief it. I didn't talk about what the answers were. I had them fill out their little sheet again. And the way I set this up is that I had these coded with the same numbers. So you had a white sheet of paper and you had a blue sheet of paper, and they both had the same number. I had people fill in the first one, and then after exploring, I had them fill in the second one. And then we debriefed and talked about the big reveal at the end after I collected all of these pieces of paper. This is cool because it engages them in that prediction process. Once again, they have to put forward an opinion. They have to own that opinion. They're then engaged and excited to see what the answer is. But the other super cool thing about using this particular method is it turns out that first prediction works out as a pre-assessment of their content knowledge on the topic, and that second prediction works out as a post-assessment. I get to find out what did they know coming in and what did they know going out of just that experiment. Even before I start telling them all of my fancy explanations why, I get to see what just that time playing around and that little discussion, that little added information did for them. And then we get to do the big reveal and pull it apart a little bit and reinforce whatever it is that they gained or perhaps did not gain over the course of that experiment. So then we come to the big question. I've delivered to you this big fancy new system. Does it actually work? Does this actually improve people's content learning? And here is what we found. So this same study that we looked at before, where we only had 25% of people walking away accurately remembering concepts, we had lots of people remembering concepts inaccurately. In this same study, they applied sort of similar principles to what we did. And they said, look at this. We get up to 50% of people remembering things accurately if they are asked to make predictions before a demonstration starts. So just by engaging their brains, just by having them make that investment of taking a guess about what will happen, people are more likely to remember what will actually happen. And this making predictions is a little bit more overt than just be like, take a moment to think about what you think will happen. This works much better if you actually have people somehow vocalize or write down or talk to their neighbor or do something, but actually have them own in some way what their prediction is. A lot of times if you ask people to make predictions in their head, they'll just get into this fuzzy land of being like, I don't know. And that's not really a prediction. You want them to actually vocalize it or state it a little more overtly. Even if their prediction is out loud, I don't know, that's still a little bit better than just letting them daydream in their head about it. The other exciting thing they discovered, 75% of people remembered information accurately if you ask them to make a prediction and let them explore with the materials, with the topic, with the information before you actually do the demonstration. So we get from 25% to 75% by adding this opportunity to make a prediction and then this opportunity to explore, to learn a little more, to try a few things out. These things really engage people's brains, engage their connection to what's happening, and mean it's a lot more likely that they're going to be able to walk away from the situation with the info that they need. So I learned about this from my colleague and learned about this information and decided to put it to the test myself, not just with the experiment that I showed you, but with a couple of others. And I also gained some data that really seems to support that this method, this storytelling approach, makes a really big difference. So I did a couple different experiments, one involving having students explore what materials would attract to a magnet and which ones would not. I used little slips of paper, kind of like the ones I showed you with the previous experiment. And I was able to demonstrate that my students improved their understanding from 72% accurate about what would happen to 94% accurate. So this one's maybe not as exciting as some others, in part because I had them come in at such a high level, but we were able to see a notable improvement. And the other thing about this piece of information that was useful is it let me know that 72% of my students already knew the information I was trying to teach them. So maybe it's something that I didn't need to prioritize with that particular collection of people as much as we thought we did. I also did a very similar experiment looking at which materials could be used to generate static electricity. And this one, there was a much more dramatic jump. We went from 48% accurate to 86% accurate. So this one was good because it showed me that fewer people understood it to begin with, and we were able to get it up much higher by the end of the experiment. The electricity experiment, the one that you saw earlier, had much more dramatic results. So in this case, I allowed students, I compared not just the accurate and the inaccurate, but the folks who also responded, I don't know, at the beginning. And my pre-assessments, I had one student, I believe, in the entire group that I saw of about 250, one student was able to get the correct answer before the experiment. By the end, we were down to nearly 90% of our students were able to get it accurate. And that was a shift from, a good chunk of I don't knows and then a whole lot of wrong answers. But to get from essentially 0% accurate or 1% accurate to nearly 90% accurate was pretty exciting for us in that case. It showed both that this was a topic we should be teaching because people didn't know about it, and that our experiment and the methods we had them working on were very successful. Another example is we use this as a way to improve our programming. So we used a really similar model of having people make predictions and then gain information and make them again in a program about surface area. And then we took that data after we did a show, as you can see on July 13th, and the numbers weren't really where we wanted them to be. So we made some adjustments to the show for our next performance. It got a little bit better. We made some more adjustments, and then our last few were all pretty strong, which was really exciting for us. So this can be used not only to show that what you're doing is working, it can be used to help you make it work better, help you experiment a little bit more as you go along. We don't always need evaluation data in every case, although I find we need it in most cases when it comes down to it. But it can also be useful for you, even if you don't ever intend to share it with other people, but just to know that what you're doing is working, or to figure out how when you tweak it this way, it gets better. If you tweak it this way, it gets worse. It can be useful for program development.